I've completely blown it. So anyway, we're here, it's a closing session. We're here to talk about the road ahead with the technology and slightly wider than that. A lot of it's going to be live, so bear with me as I go through it, but let's start. The first thing on our road ahead is not our technology. It's the thing that we all face as a society and that we all have to deal with, and that's climate change. It's the biggest problem we face as a species, and you're in a place to help with how we understand it, how we communicate it, how we mitigate it, how we deal with climate change, how we reach net zero and all those other things. As part of preparing for the conference, we reached out to some of our colleagues around the world because the whole planet is facing this problem. And we got some very interesting presentations back. This is from our colleagues in the Middle East and Africa. And they talk very quickly about the problems they're facing as a continent. So coastal change is a major one, flooding, rising sea level, and so on. And we'll share these slides with you. I'm not going to go through them in detail. But you can see the sort of the problem and the approach to solving that problem that people are taking using GIS. Food security is a massive issue. There's 1.2 billion people, and there's a lot of climate forced migration and different climate environments and so on. Food is a really, really important issue, especially when we see the sort of things happening in Ukraine, which make everything harder. Climate change, the impact on community. It's causing people to move around. It's changing how communities work and how they need to communicate with each other. And if I go through this, and then I'll just step through Asia as well. So the same, we went out to our colleagues in Esri, Asia, Southeast Asia especially, and asked for their view on what was happening with climate change in GIS. And once again, it's migration, and the problem's migration. It's rising sea level, it's extreme heat, it's too much or too little water, water in the wrong place. They're facing the same problems that we are facing here. It is a global issue, and they're tackling it using GIS to help with all of these things. And this is something that we can do here in the UK and are doing. So I'll just go out and show an example. This is a site that we have showing climate change stories from around the UK. It's got various organisations doing really, really good and important work using GIS and geospatial technology and content and so on to try and improve the environment that we're in, to try and communicate about it, and so on. You are in a really unique position where you can help with this. Many of you are doing work that will contribute to this, and I would really, really encourage you to share what you're doing if you're working in an area of climate mitigation or anything else related to it. Share it with others as inspiration to help them do it, or learn from what other people are doing. It's a really, really important area. I just encourage you to engage with it. The technology, I'll go on to talk about this a little bit, but the technology that we work with, the science that we work with, is very, very special, can help tackle climate change in a way that few other things can. It's a responsibility we all carry. So with that, I'm just going to move on to the tools that we use to do these things. This is what we commonly call the jack arrow. If you're an Esri person been around for a while, you know what the jack arrow is. It's up and to the right. And it has a word cloud. We've been doing it for years. One of my colleagues in Esri, Netherlands, took Jack's word cloud and put it into ArcGIS Insights to monitor the change in the size of the words over time, to see what Esri was doing. But this reflects what the areas that we're focusing on as research and development. And Esri, we have about 2,000 to 2,500 developers in our development team. It's a real engine of development. And we spend about $400 million a year on R&D to progress the science of GIS and to support what you're doing. And we're trying to achieve many things. One of the major focuses is enterprise scale GIS. Increasingly, GIS has been asked to perform at scales that we couldn't have imagined a few years ago. And it's totally mission critical technology. Go back 10, 15 years, and sorry, but if the GIS department was out of action for a day or two, not many people may have noticed. But now we're at the centre of businesses and the centre of society and how it deals with all the problems it has. We are the engine of many economies. The sort of data you work with is really important, and the systems have got to work securely. The impact of security and hacking and ransomware and everything else is very real. If our systems cannot sustain that, nobody can get the benefit out of them. They have to scale, so we put a lot of effort into scaling the technology and making sure that as demand grows, we can grow with it. But once again, you'll get this slide. Everything on here is an active area of research that Esri is carrying out, and we continuously are developing this. Our release cadence of our products, I'll just wait for you to read all of that. Thank you. We release our products frequently. This is the plans for the rest of the year and early into next year. And basically, There's a real cadence of release for all the products. And if you want to know what's next and what's new and what's in our roadmap, use the blogs on the website, because they're the most up-to-date source. And one secret is inside Esri, we tend to use the blogs. We've got much better as an organization at publishing information about roadmap and direction and change. And because we're releasing so frequently, we don't really, we basically gather the work's been done every few months. We say, is this ready for release now? Yes, it will go into the release. So they do tend to change and mold, but they're regular release cycles, which leaves us able to respond much quicker. And we really, really need your input and feedback. I've mentioned this in the past, but I am fairly convinced that per head of population, Scottish people break our software more than any other nation in the world. And that, for our point of view, is a good thing because it helps us get it better. So do not stop in providing the feedback. Maybe try not to break it as much, but please provide the feedback. We need it, and we need it to improve these products. The only specific thing I want to call out is there's new versions of software all the time. The new release of Online is coming out, hopefully November the 9th. Sometimes it shifts a day or two. And there's a load of new things in here, and we've talked about ArcGIS Online a lot today. It is the sort of forge within we create most of our software now, and then we take it and put it into enterprise environments and on-premise environments. It helps us, because it's a consumer sort of facing product, it gets a lot of usage, and functionality we release in that environment gets tested. And it keeps it up to date. It's always the latest version and so on, because we're providing that as a service. One of the things I'm most excited about in the next release is actually buried in here somewhere is the new editor for Arcade. I don't know if you've ever worked with Arcade, but the editor you had to learn to love it. This is a better editor, so enjoy that. Right, what I really want to talk about isn't specific products or technologies or pieces of new functionality. It's trends that we see happening at the moment and what's driving us in our roadmap. And most of that I'm hopefully going to do with live demo, so bear with me. I'm going to close things down. This is my ordinary work laptop that I use for doing emails and everything else. If it can do it, most of your laptops can do this stuff. Earlier on, when Claire was doing the opening plenary, you saw her using an AI model she got from the Living Atlas. We think that the application of artificial intelligence techniques to GIS is it's just a really important area. There's going to be a lot of innovation coming out of that, and it's been used extensively already for things like image detection, change detection, but we're starting to use it in ways we never even thought of in the past, and at a scale that we couldn't have worked with before. So you can literally go and download an AI model that we've trained, because one thing we've learned is many customers can create AI models, but it's expensive work to create, and it's hard to create them and hard to have them work well. So we've created these ready-to-go models for all different things that you can download and use yourself, or you can download and retrain and tweak to make it more local and something. One of my favorites is the palm tree detection, which you may not know was actually trained in Plockton. That's a real story. But this accessibility of AI is really changing things. And a good example of what we're doing with it, this map is a map of it's land classification for the whole planet. So we work with some of our partners, and we pull in the Sentinel data all the time, and we process it using an AI and basically categorize the whole planet into land use categories, 10 different categories. So this is a world view. Here we have Scottish view, and then here we have the Perth view. And then if we hit play, we should see there's not a huge amount of change going on around Perth, but you can see a change in land use over time. The scale of this land use map would just cost too much money and take too much effort for us to take that data and categorize it in traditional methods. But we can take an AI, we can train it for a specific task, and it can generate this sort of information that we can then rely on and track over time. The end result of this stuff, imagine the Ordnance Survey. They capture remote sensing data, they capture survey information, they put it all together into a system, and they create master map. In theory, with the appropriate infrastructure and AIs, we can take raw survey information, pour it into a funnel, and at the bottom comes master map without a human having touched it in between. We can create these vector maps that we use, or we can create other products from it we haven't thought about, not just a replacement for something like master map. We can create entirely new products. So raw survey comes in whatever mechanism, real time, aerial photographs, LiDAR, and out comes things that we can work with. And they happen in real time or continuously updated. It's an absolute change. And the application of things like Python notebooks to be able to automate all this, there's a real opportunity for using AI to do things at a scale that we could never even imagine before. One of the areas I'm really excited about is Point clouds are quite easy to capture now. You can take pictures and generate point clouds from them. You can get LiDAR information, but extracting meaningful content from that is actually quite hard. You know, you do a survey of something and you want to check the quality of all these chairs. How do you know it's a chair? How do you know when you survey it again, it's the same chair and its quality has gone down and it needs repaired? That's what I'm hoping we are able to do, and there's a lot of research going into that. Another area we're doing a lot of work on is developers. We've talked about configuration, and configuration is really important because it lets us get up to speed quickly and have meaningful operational systems at low cost and easy to maintain. But development allows us to do things we couldn't do in other ways. And when you're thinking about ArcGIS, we've designed it and built it so everything is accessible through an API. Every application you've seen today, behind the scenes, there's code which is calling an API to do all the functionality you've seen. And we're really improving the documentation of this. We have business models for developers that are free, that scale, that pay as you go. And there's all different ways of interacting with it. But we have this amazing set of development tools that let us do things that, once again, we couldn't do any other way. Some examples of this. This is an application that somebody's put together at Esri, showing satellites around the Earth, and I can click on one and I get information of that specific satellite. It's another good example of how important 3D is, because this map in 2D or this application in 2D would not be the best. But it's a really good, interactive, just fun to play with application that only a developer with these sort of tools and power could actually put together. Another example, this is some imagery, and I can click on these sliders again, like John just talked about, and I can change the hill shade. All happening client-side in JavaScript in real time. It's very compelling, very easy to work with. Another example, this one is Landsat Lens, and let's hope it there it goes, come to life, so you can do this, it's great. Let's go and have a look at Perth. Let's get the right Perth. It's here, so now I have, it will load in eventually. So there we have Scottish cloud, move around. I'm going to change this, I'm interested in the vegetation index, and I'm also interested in 2002. So now I have this window, if you can see, is 2017 data. This is 2002's data, and you can really explore and learn things about it. It's a very compelling application once again. A developer's put this together with it. You know, I want to create an app that does this and does it really, really well. Yet another example, this is a map, I've shown this one before, but I just really like it. It just does its job very simply. It just shows us the average temperature across the world. And unfortunately, as we go to the right, the average shifts. Very compelling application. The animation and everything else tells the story very well. Developers with access to these tools can create amazing things. It's one of my favorites. You click somewhere, it does a drive time. This is a 5-minute drive time. Let's go for a 6-minute drive time. And it shows the results. It's telling you what shops are nearby. And it shows the results by revealing a different base map. That's all it does. There's 2 base maps. It does a drive time, and then it uses a mask to show you the other result. It's very interactive, very compelling app. It might not make you go shopping, but it does make you explore the area. So it's cool. The other area where we're seeing a lot, we've talked about 3D today a lot. And 3D is not 2D in a different dimension, or maybe it is, but we've always worked with 2D data as GIS people, and I would suggest that one of the reasons we've always worked with 2D GIS is it's a lot easier than 3D. It's a lot quicker and easier to make a map, but we as humans experience the world in 3 dimensions. And it's actually a skill to learn to read a 2D map and transpose it onto that 3D lived environment. The technology has now got the point. I look back sometimes at presentations I did in the past, and I look at 2010, it's like, what's happening? What's the next big thing? It's 3D is the next big thing, and then 2012 and so on. It almost is. It's great. The technology has caught up to the point where we can capture the data in 3D and we can render it, and it opens up use cases that are just too hard to do in other ways and can be used. Now, this is obviously not Scotland. This is, I think, Rotterdam. And it's showing space use in an area of development in Rotterdam in a way that if you were trying to do this in 2D, you just couldn't convey the information. It's showing the use of space across these things, retail space, residential space. There's one layer here which is showing risk levels to do with egress from the building in sort of, you know, if there's an emergency or so on. You couldn't understand this information and manage it and learn from it unless you use the 3D presentation technique. Here's I was playing around with ArcGIS Online, just looking at what data we have for Scotland now, getting ready for today. This is something I created just with the ordinary ArcGIS Online Viewer data that's available on Living Atlas, and a few minutes of playing around. You can tell it's live because it's loading in as we go. And it's just incredible what you can create and how accessible this technology has become. The data still needs to get better and more available, but it's rapidly happening. And you have access to this, and you can tell stories in different ways. And if you use this sort of presentation, members of the public can engage with it in ways that they're not able to with traditional two-dimensional maps. Also, the analysis that goes with this is very different. Analysis in 3D is very different. You're dealing with volumes, not just flat areas. If you're dealing with noise pollution it's a three-dimensional thing. It comes out, it's four-dimensional, it comes out through time. All the algorithms behind the scenes need to understand and work in 3 dimensions. If you do a buffer, it's not a line along things, it's an actual volume of space, and every piece of analysis that says who's being affected by this needs to understand 3D, and that's what we've done and what we're continuing to do. And there's still a lot more work to do to get this to perform better and be easier to use and not need the level of graphics hardware that it does, but it's really, really come of age, and there's a lot to learn. That presentation in Glasgow earlier on is really inspiring in what we can do. We live in a 3D world, we need to use 3D technology better. It's not just buildings and so on, this is reality capture technology, and we can show you this. We can go out and fly a drone and produce really detailed 3D information quickly. So this is an example of a stockpile of minerals somewhere in Australia. And imagine you are trying to understand your supply chain. You're building an electric car, you're sourcing lithium from somewhere, and you want to tell your supply chain is sustainable, that they have produced what they said they've produced at the source. This is a way of understanding that. We can go in and we can do volumetric analysis and what type of material is this, how big are the mounds, therefore is the amount of material that I'm trying to make sure is available for my supply chain, is it available? And there's other really interesting things around sustainability in supply chains, because if you map out a supply chain geographically, you can start asking questions like, is my supply chain environmentally sustainable? Am I pulling in materials from areas where there's a lot of human rights abuse? What can I do to mitigate that? Where could I move to? It's a really interesting area. But the ability to scan and process 3D information and turn it into meaningful information is just very, very important. And then building on that, I'm just going to hand over to my colleague Mark. Did I give you enough time? And he's going to show you a bit more that we're doing around 3D and engagement and interactivity. Thank you, Mark.
Thanks, Charles. So game engines are a technology we've been working with for a few years now. And off the back of that R&D project, this year in July, we released 2 new products for bringing in GIS data into game engine technology. So this is the Maps API for Unity and the Maps API for Unreal Engine. Now you may ask, why are we playing around with this technology? Is this just a fun project for the development team to work on? Well, yes, it is. But it does have some really good real-world uses. Now I see this as being giving us the next generation of 3D GIS. So going back to that question, why game engines? What we're doing here is we're bringing together 2 complementary technologies. So we're taking your GIS data and the way that we can render that, and we're bringing that into a premium rendering experience that the game engines give us. So this isn't just for traditional 2D displays, traditional flat screen technology like on the projector screen behind me. This is also for extended reality that encompasses augmented, virtual, and maybe mixed reality. Now the game engines give us easy access to libraries like physics engines, animation, and special effects like viewing your data in different weather conditions, like on a misty day, for example. And the game engines allow us to be able to deploy our applications to both mobile and desktop platforms. Now, to give you a flavour for what's involved in working with a game engine, I'm going to switch over to a project that I've started to put together in Unity. Now, I'm using the Unity component view here, and you'll see that I've added in an ArcGIS map. Now to configure that, it's very straightforward using the plugin that we've created. I'm going to open up the map creator, and here I can define the map area and the camera position that's looking down on the data that I want to work with. And then it's a case of just bringing in your GIS data, so the base map and the elevation data and the layers we want to work with. So you can see here that I'm working with a building data set from Munich in Germany. And that can be further augmented by bringing in data from the Living Atlas or your own GIS data. And having added it in, I can now interact with that. So you can see it's quite easily achievable to start creating one of these applications, and the story for working with Unreal Engine is very similar. Now, talking to our customers who have started to embrace this technology, I've been really impressed with the range of use cases and also the different industries making use of this. I think this list speaks for itself. You'll notice that game developers are there, but they really are in the minority. Now, people are using this technology because it gives you a new and immersive way to interact with your GIS data. And this is using consumer technology like augmented reality on your phone or virtual reality headsets. But what this is doing is it's opening up your GIS data to a much wider audience. So a member of the public, for example, could visualize a new building proposal and look at that as if they're outside the building. They could go in to explore what it's like inside. Then they could then go on to have a look at the effectiveness of the street lighting at different times of the day and in different weather conditions. Exactly that same data could be used by an emergency planning team to be able to look at the viability of emergency exits in that building and then maybe add a little bit of smoke to make it a little bit more exciting. So these are examples of why you would use this technology. Now, to finish off, I'm going to move over to my PC, where we've got an application which has been written using Unreal Engine. So this is an app that we've created for looking at potential landing zones for an emergency rescue helicopter. Now, because this is a game engine technology, I can switch between third and first-person views, and I can get the pilot's eye view, and then I can go and take a look in the back seat of the helicopter, make sure there's no pilots to criticise my flying skills, and then I'm going to attempt to fly this over Munich. And I haven't crashed into anything so far, that's good. So here we've been looking at our two new developer products, the Maps API for Unity and the Maps API for Unreal Engine, where you too can create immersive GIS experiences with game engines. And if there's anybody who has got any ideas for how they want to use this technology in their own environments, I'd be really keen to speak to you. So with that, I need to work out how to land this, so I'm better hand back to you, Charles.
So the other area we're doing a lot of work is, another area we're doing a lot of work on is indoor GIS. If we can just change the screen over, please.
Yeah, because I'm going to crash it.
Okay. There we go. So indoors GIS, once again, 3D, but the capture of indoors information and the integration of it into the outdoors information is really, really important. We're putting a lot of effort into this. This is an example of a 3D building, and the inners of it have been cut, and you can see we can move into the room, and then I can go to here, and you can see that this desk, somebody's working with ArcGIS Pro, and they have 3D on that. If you zoom in on that, it comes out the back of the room, and it's just, yeah, whatever. This is more indoors thing, but we're moving now into the realm of digital twins and building information models, BIM models. This is an incredible 3D capture of data from a CAD system where I can click on any element and I can see what its insulation and what type of insulation it is. We can store and process and manage and display and interact and analyze vast quantities of information. And this is a really, really important area. When we start getting into BIM and digital twins, which I'll talk about next, we're starting to see GIS moving outside of its traditional environment. We've seen it really sort of merging and influencing the world of data science. Some data scientists who come from a data science background actually understand geospatial these days. Not as many as I'd like, but it's definitely increasing. But the world of BIM and building models and management of sort of buildings and so on is increasingly working in the world of GIS. And that gives us an opportunity to broaden the understanding of what's possible with GIS. Digital twins are a really interesting area. They quite often come from an engineering background. People use the word digital twin to mean anything from a point cloud to an actual proper finite element model of a bridge or something. A digital twin is a system that allows us to model and predict a real system. It allows us to maybe control that real system. So if that real system is a water network, we can use a digital twin to monitor pressure and change behavior. We can also use it to predict the future. If I have an extra 1,000 properties I need to service, have I got the infrastructure to do that? If there's leakage in this area and I mitigate that, how much will it cost for me to do that? So on. They're really important areas, but it's very, very important because it takes us into a world where GIS is overlapping with other sectors. If you want to take various digital twins and put them together, what's the thing that joins them together? It's location. How do I know that this bridge that I understand the weight loading on connects to this transport network? Because they touch each other. How do I know that this area that I've put an electricity substation on is going to be affected by flooding? I know that they're in the same place. I have a flood risk map. I've got the map of where my stuff is. It's a very, very important area, and it's something we're investing heavily in. This is an electrical network somewhere in North America, and we are working in a browser, and we have a model for how this network works. So any piece of equipment in here, I can go and I can select it. So let's just go and I'll make it full screen, make it a little bit easier to see. I'm going to select a piece of equipment, and I can trace from that, I can visualize it, I can get its properties, but I can also look at the network aspect of it. So here's that piece of equipment. I hover over it, you see it highlighted. It connects to this piece of equipment. I can click on that and expand that and see where that connects to. And I can see how all these pieces of electrical equipment connect to each other. But more importantly, I am modeling the electrical behavior of this network. So if I say to it, I want to put, there's going to be 50 extra houses with solar panels feeding into the network, can it cope with that? And this is very focused on utility type work, but it affects every part of our life. We can now model water networks, gas networks, telco networks, electricity networks at a level of fidelity that allows us to predict behavior and to model better in the future. And this is a real big area of research for us. It too is an area which is increasingly being used in 3D. So let's go to this view. Here I've got a split view, and you can see it in 2D. I'll just pan around the map. So you can see the 2D view and you can see the 3D view at the same time. It helps us understand and contextualize the network much better. If I go and select something over here, let's just select something, and I'm going to do a trace. Let's do a trace, and I'm going to create a start point, and I'll put the start point here, and I'm going to do let's go for an upstream trace, and we'll say run the trace. And it will basically electrically trace that, not just what's connected, but what electrical connections are there, and it should come back with, I think it came back with an error. So we'll try again, let's go somewhere else. You can tell this is live. I'm just going to go to an area that I know of, and I'm going to try this one more time. So we are going to take this device and it's not going to work. Imagine that I just come out with a lovely blue line showing you what was connected, and then I went into 3D and I showed it to you in 3D. And what you would see is an engineer can see a trace going through a network and understand it and contextualize it so much more than on a 2D map, and really understand where they need to take action. So this is another area that we're putting a lot of effort into. And the final thing I want to show is, in many ways, the least visually compelling. This is an electrical network. It's a made-up one in Edinburgh. And I'm interested in extending this network to service some new houses or some renewable energy or something. It's in a part of Edinburgh which is quite busy. There's a parliament there and other things. As I move this mouse around, you see these grey lines? They are telling me the distance to tree preservation orders. If I'm going to put a cable underground near here, I need to be aware that there are tree preservation orders in this area. If I move down here, you can see there's a listed building. Down here, these are abandoned gas mains. Over here is contaminated land and a triple SI. I'm moving a mouse around, which is giving me an X and Y location. I'm doing it at a time, so I've got a timestamp location. We understand the height of this thing, so I have a 3D and a time location. And I'm using that to ask questions of the surrounding area. Each one of these highlighted listed buildings or trees or gas mains, they are digital twins owned by different companies, different organizations. And I am asking questions of all of them simply by moving a mouse. I'm using geography as the key to link multiple data sets together. If I come in here and I create a new power line, first thing, my digital twin of the electrical network has said, you want to put a new power line? You can only put them at these yellow places. I create this line, and you see the yellow box in the top right? It's telling me the cost of materials, the cost of construction, and a list of constraints that I need to do, which organizations I need to work with. This is a really important principle, and I know it's a really basic principle. Geography is the key to unlock the data that the world holds. It's the key to join these data sets together. And you are the people who know how to use that key. You can help people link information together and tell better stories. You can help us as a society mitigate climate change, because you can pull together all these data sets. It's becoming easier and easier. Our development efforts are to make this more available, more scalable, easier to access, easier to work with. That's our job. Your job is to work out what to do with it. Thank you very much.